This is Techno, a show about innovations that can change lives.
The science of fighting a wildfire.
We're going to explore the intersection of hardware and humanity, and we're doing it in a unique way. This is a show about science by scientists. Let's check out our team of hardcore nerds. Cara Santa Maria is a science journalist and educator with a background in neurobiology. Tonight, it's the house of the future, heated and cooled by the Earth, able to generate its own power. One of the greenest homes on the planet. Now we put UC Davis's Honda house to the techno test.
I get the big room.
We're moving in. One night, 2 techno contributors, and our camera crew. Can we survive life off the grid?
What am I doing wrong?
Dr. Crystal Dilworth is a molecular neuroscientist. Maria Davison is a biologist specializing in ecology and evolution.
You did it.
And I'm Phil Torres. I'm an entomologist. That's our team. Now let's do some science. Hey guys, welcome to Techno. I'm Phil Torres, joined today by Dr. Crystal Dilworth, Marita Davison, and Cara Santa Maria. Now, this week, guys, Cara and I went on a little adventure. There is a home called the Honda Smart Home, and it's probably the most eco-friendly, energy-efficient house on the planet. While most people just go and take a tour, check it out, Cara and I decided to take it to the next level, and we had a slumber party for science.
For science.
Absolutely for science. Let's take a look. Believe it or not, Cara and I are doing this for science.
It's mozzarella time.
And this. And even this.
Huh.
You did it.
Smart TV.
Smart Cara.
We are pioneer guests in a 1,944 square foot laboratory for sustainable living. Honda has teamed up with the University of California at Davis.
We want to get to a zero carbon future.
And if this is what zero carbon emission living looks like, it's one awesome place. When you walk in, it's a full-on dream home.
So this is the Honda Smart Home.
Welcome.
The ground floor is filled with modern furniture. Chairs, couches, and rugs, all made from sustainable materials. Even the floor, polished concrete, was constructed in a way to reduce carbon emissions. The kitchen is sleek, modern, and filled with top-of-the-line appliances. Upstairs are the bedrooms, 2 of them. A master with a killer bathroom and another nice standard-sized room. I've got my eye on the master. So why is Honda in the house business? To build a home that can power itself and an electric car with energy to spare. Michael Koenig is the project leader for the Honda Smart Home.
Honda's involvement in this house would seem to indicate that they're interested in more than just cars in the future.
Right, so as we get more and more electric vehicles, we're going to have to be more careful in the way that they integrate with your house and how they integrate with the electrical grid. And so by putting the house and the car together as a system, the system can be more than the sum of its parts.
While Honda is not releasing the cost of their smart home, the company says without its experimental technology, it would be similar to other high-end homes in Davis.
So what's it been like so far for people to come here, to stay the night here?
Well, this will be the first night for anybody besides myself to actually stay here. So
All right, so we're doing the first outside slumber party.
You're the first overnight guest.
Drop your stuff?
Shall we?
I get the big room.
Once I nab the big bedroom, in the name of science, I decided to take the Fit EV for a spin. Now, with most cars, you have to actually drive to a gas station to fill up and re-energize. But with this guy, I just drive it home, plug it in, and the sun does the rest of the work. I'm kind of digging it. Hopefully Cara will let me drive this around for a while. That must be Cara. Hello. I am having way too much fun driving around town right now.
But I want to drive the electric car. Bring it back 5 to 10.
You got it. See you soon. While Kara took a spin,
Bye. Don't wait up.
Michael showed me how the house was built to make the most of the sun, whether it's low in winter or high in summer.
We've got all these lovely south-facing windows, but they're all shaded. So when you get into the summer, we don't get any extra heat gain. But in the winter, we harvest a lot of free energy.
And then the solar panels, are those up on top here?
Right, so architecturally, we have a little bit of a modern form with this very large shed roof, and that was, again, form following function. We wanted to have as much clear space as possible for the solar panels.
On a sunny day, the solar panels can produce as much as double the energy that the house actually needs. Here's where some of that extra energy goes.
This is where it happens.
The right side here is a 10 kilowatt hour lithium battery that we can use. We can store solar power in here, we can charge the car, and we can use this to buffer our energy flows back and forth to the grid.
Wow. Now, if, let's say, there was clouds over here and you weren't pulling from the grid, how long could this charge the house, or how much could it charge the car?
It depends on what you're doing in the house. And if it's just off the battery, you could easily run 10, 15 hours, depending on what you're doing in the house.
But the brains of the house is this, the Home Energy Management System. It's a prototype built by Honda to balance supply and demand in the house and integrate it with the electrical grid.
Data collection is happening, about 270 channels.
Whoa.
All of the temperatures, all the electrical loads, all the water flows, all being monitored and recorded.
What was that clicking?
That's the way the data logger ticks through all the channels as it records them.
While Phil was getting the big picture from Michael, Jonathan Woolley, an engineer at UC Davis's Western Cooling Center, showed me some of the house's cutting-edge technologies.
We're heating and cooling the house through radiant systems.
Oh, so this is completely in lieu of having traditional central AC or central heat.
Yeah, absolutely. So instead of moving all that thermal energy around with air, we move it around with water, and we deliver that heating and cooling through the floors and through the ceiling.
If there's just cold water swimming around underneath and above me, how is that physically going to make me colder?
So it turns out human comfort also significantly is impacted by the temperature of the surfaces in the room.
One of the experimental systems that UC Davis is testing in this lab is here, underneath the backyard. 4 20-foot deep holes have been drilled into the ground to create a geothermal system that helps to heat and cool the house and its water.
And we've dropped a helix of tubing into those holes, and that tubing carries the working fluid that runs back to the heat pump and exchanges heat with the ground. It's picking thermal energy up from the ground, because that cold water might be going in at 45 or 50 degrees, and the ground is 55 or 60 degrees.
So even if it's just a slight differential, the ground itself is warm enough to put that energy into the water inside of those tubes.
Exactly.
And in this house, nothing gets wasted, not even the heat from this water. Instead, it goes into this heat recovery system.
So the hot drain water runs down the inside of a perfectly straight pipe, and the cold water that's coming into the house wraps around the outside of that drain line.
And so as it's coming in, it's warming up so that it takes less energy later to make it even hotter if we needed it.
Exactly.
Brilliant. It's nice and cool in here, though.
It is.
Then there's the lighting system. Solid state LED and 5 times more efficient than conventional lighting. But the lights are also designed to work with our own internal body clock.
So you designed all of the light in the Honda Smart House.
Yes, we're wired internally to have lots of daylight in the morning, okay?
So that's blue lights.
At nighttime, what you want to do is the reverse. What you want to do is limit the amount of blue light that you have in the home. You want to use lights that are warm and biased towards the red. The whole house quietens down, shifts towards the red end of the spectrum.
Equally important, the lights are designed to make us look good.
People want a warm glow to their light bulb. I want to be able to look in the mirror in the morning and do my makeup, and I do definitely notice that the colors are very vibrant. They really pop in this house.
Now, my first impression of this house, I was so impressed with their attention to detail. Didn't you agree?
Oh, yeah. I want to move into this house the second that I saw it. It was beautifully designed. It was, the architecture was amazing. The interior decoration was amazing. And then we started to realize that every single square inch of that home was intentional. It was deliberate. It was designed in a really eco-conscious way to work seamlessly together for you.
Yeah, even the insulation that they used was 85% recycled newspapers and denim, of all things.
Wow.
They were just so thoughtful in their attention to detail.
So it seems like a lot of the technologies in this house have been around for a while in terms of green design. What is it that's, taking the house to the next level?
The home energy management system, which is basically communicating with the power grid, communicating with the solar panels, the car, every single circuit in that house, tweaking each one to add just even extra 5% efficiency. That's really where I think it stands out.
And one other really cool thing, a lot of houses lose energy because they have leaks. There's little cracks in the walls, the windows don't seal appropriately, and usually a builder will have to go through and caulk up anything they find. In this house, there was an ingenious approach to insulation. They actually pressurized the home and sprayed in a nitrogen solution that would go straight to all of the cracks, seal them up, and then when they depressurized, they knew that the house was completely airtight.
It's crazy, and this was experimental. Like, they haven't done this in a lot of places.
Were there major differences that you guys noticed because that house is so special?
To be honest, no. I mean, that's the really interesting thing about this house is that everywhere from the HVAC to the lighting to the electric design, the intention was to make this house feel very warm, inviting, and livable. So in many ways, they thought about the feeling of the home before they thought about how to make that feeling energy efficient.
I mean, we were living in an experiment, and you guys are about to see us next have a slumber party in that experiment. The Honda Smart Home in the West Village at UC Davis. Almost 2,000 square feet of technology and progressive structural design. After an extensive tour, Michael demonstrated how to use the iPad, which controls the house.
So this is the actual temperature of the whole upstairs, of the whole downstairs.
Right. So the 76 is measured by that sensor there.
Okay.
This device not only controls the electronics, it also shows your energy usage in real time.
And so, but we're completely off-grid here, is what it says.
Right,
We are off the grid. Michael gave me some final instructions on the clothes washer before leaving us alone, in a house that's smarter than we are.
I'm not a very good cook, by the way, so we're gonna work together to not suck at cooking. Ah, perfect. We'll be there soon.
Fast preheat. Start. What am I doing wrong? On, off. I pressed that button, I swear. Okay, 350.
350.
Press start if ready. Boom, preheating.
While we were busy cooking, the house was busy too, adjusting the lights for evening and tracking data, minute by minute, checking where the power is going and where it's not.
What are you guys hoping to learn from this?
We'd like to help propel the state of the art in the industry. And so most of that data we're going to make publicly available. We're going to put it out on the internet. Anybody who wants to study actual energy usages, and then they can use it to develop better equipment.
That looks beautiful.
Time to bake. We want to cover it at the first part.
Can we like take a before and after picture? I'm gonna do that.
Are you going to take a lasagna selfie?
A lasagna selfie?
Would you like to do the honors?
I would love to.
Okay. Heating.
All right.
Okay, so now we might as well.
I'll let you clean up. And so we're about to find out how energy efficient lasagna tastes.
Oh, I really hope it tastes good. I feel like my reputation's on the line here.
Sure is. That's really good. I am enjoying this. Well
You're not
done.
faking like you're enjoying
I'm
it?
not faking. This is 100%.
Great.
Then it was time to relax and check on our energy usage. With this tablet, you could tell how much energy you've produced, how much energy you're consuming, and you can also have a little bit of fun. A little TV, a load of laundry, a nice hot shower, all for science. Then it was time for us and the house to go to bed. The next morning, our scientific slumber party came to an end. It was time to turn the house back over to Michael Koenig.
So, how'd it go? You're the first overnight guest. Tell me the truth.
It was exciting. I loved it.
Oh yeah, we trashed the place. It was a lot of fun, though. It was a whole lot of fun.
Some of the appliances were almost a little too smart for us. It took a little bit to catch up.
It took Phil a while to figure out how to turn on the oven. I'm just gonna say.
Me too.
You know what's really cool is that the water is hot within like a second.
That even saves water problem.
Definitely.
Yeah, that was the design.
I love the way it woke up with us this morning. You know, I was sitting in my bed doing some work, and then all of a sudden the shades go up. And, you know, it feels very, very connected to the house, not just with the way the lights are, but also just knowing that everything I'm doing, it's being recorded. So when I flush the toilet, go in the shower, all this data goes to science. Of course, we were energy hogs because we came with a full crew and a lot of electronics. Honda says the house is expected to consume around 18 kilowatt hours a day, much less than the average American home, which consumes about 30. The house delivered more than 19 kilowatts of energy back to the grid. Well, Michael, it was an honor being the first guest here. I think we both had a blast. So thank you so much for letting us crash in the Honda Smart Home.
You're very welcome. We'll be happy to have you back.
Oh, we're gonna come back for sure.
We'll save you some lasagna this time.
I appreciate that.
Goodbye, home. So needless to say, I had a really good time. I kind of want to move into that house.
I am really jealous that you guys had a sleepover and you did not invite us.
It was hard work, okay? I was testing out every little faucet, eating lasagna. It was
Delicious lasagna.
Now, what about the accessibility of a home like this? I mean, would this be affordable for the average American?
You know, that's definitely something that we talked about, and I think some of the items, because they paid such attention to detail, things like the tables were all certified wood. The bed I had was the most eco-friendly bed in the world and probably cost a lot of money, which is good for that example home, but I think the average consumer would have a hard time relating to that or even getting close to affording that. However, there are things like the passive design, the way the home was built with the angle of the sun, the way the windows are, and even the solar panels that I think are quite attainable.
Yeah, I think a lot of times it's about thinking about these items before you build, putting them into the blueprints. If you're going to build a home anyway, making your home have that passive design wouldn't cost any more money. But converting and retrofitting an existing home would probably be very expensive. Also, let's not forget, this is a research home. And when you're doing research, it is very expensive, but hopefully once the data come in, it will become scalable.
After having had this experience, which one feature would you each choose?
Ooh, that's a tough question.
You know, I think I'm gonna have to go with the lighting. I just loved how automated it was, how by day there was blue light, by night it was more like yellow, red light. It was just, I love that.
It helped you sleep, it helped you wake up and feel really harmonious and feel really rested.
So I'm wondering, guys, with a home like this that's contributing to the grid more than it's pulling off of it, what do you think that's going to mean for the energy industry in general?
I think that's a fascinating subject that, unfortunately, we didn't get to talk to anybody from the energy industry. However, they are working with them, so they're aware, they're kind of welcoming this type of technology, but that would be kind of weird. Instead of having a bunch of consumers out there in the neighborhood, they're actually having people contribute energy to the system.
I think that's ultimately the goal that we all want to achieve, and seeing a transition into using more solar, into using more geothermal, into using these different sources of energy. I think that we're going to be able to start to see less and less reliance on coal.
Now, as you guys saw, Kara and I had a pretty good time cooking some lasagna. It was her Texas recipe special, and that smile is genuine. I actually did really enjoy it. Well done, Kara. I appreciate it. And if you guys want to see more of our photos from the field, be sure to follow us on Instagram and Tumblr. Now guys, you are about to meet Baxter. It is a smiling robot that may be coming to a factory near you and helping out some of the workers there. Let's take a look. A human-sized robot named Baxter is redefining the way robots are being used in manufacturing environments in the U.S. Baxter is a two-armed robot with an animated face. If Baxter bumps into something or someone grabs his arm, sensors will stop the arm from moving further and allow a human to reposition it, making hands-on training with Baxter safe, easy, and intuitive. It is used for simple industrial jobs such as loading, unloading, sorting, and handling of materials. Baxter is able to work on an assembly line next to a person who trains him to learn these repetitive production tasks. With behavior-based intelligence, Baxter senses and adapts to his environment and task. So I think one of the questions that always comes to mind when you see a piece like this is this robot going to replace human jobs?
You know, I think we can look to different industries that are actually implementing and using robots right now. And the agricultural industry is one, for example, where there's a push towards automation and a major concern that it's going to displace the workforce and take the place of human workers. And in fact, that's not really what's happening. These robots are being designed to work along with humans. They're designed to, in some cases, even help them, and are also requiring that workers expand their skill sets to be able to work alongside the robots. So
I understand that these robots were designed to work alongside people, but I'm not really sure that I'm completely sold on the need to put a face on the robot. Do we need to be anthropomorphizing these machines?
Well, I think that as somebody, you know, with a PhD, you can probably look at robotics in a different way than somebody who maybe has never been around a robot before. And honestly, I think that if there's a warmth to the workplace, if robots are scary to a lot of people, Hollywood has made them scary, and if we can make them more approachable, more human-like, it might be easier to adapt to robotics kind of in the workforce.
So what you're saying is that not everyone has stood in a lunch line with a robot that is buying lunch for itself?
Probably not.
I have done that.
That's pretty amazing. I also think, I mean, there is something to just a smiley working environment. Think if anybody's working in some kind of manual labor and they have something next to them smiling, even if it's a robot, I really think that'll make a difference in how their day of work goes.
And I think it's really cool that this robot is actually reactive. So if you're working side by side and it bumps into you, it will pull back. It won't actually harm you. And I know that that's a big concern for a lot of people working in factories that could be potentially dangerous.
Yeah, so if it's safe, if it's smiling, I mean, I don't have that many complaints. I do think that it's a bit limited in skill sets right now, but this could be a good glimpse of the future of the factories and industries around us.
one of the things I really loved was that the code is open source, and so anyone from around the world can contribute.
Exactly. If you are working in a factory and you program your robot to do something specific, but your skill set is limited, you can actually learn something from somebody halfway across the globe and improve the ability of your factory. It's pretty cool.
It is pretty amazing. Now, from a robot that can work alongside you, smile at you, to a house that greets you with warm light, I'm always amazed at these stories that we get to contribute to and just find out about. So if you guys want to see more of them, be sure to check us out next time here on Techno.
Dive deep into these stories and go behind the scenes at aljazeera.com/techno. Follow our expert contributors on Twitter, Facebook, Google+, and more.